All right. Good morning, everybody. This is Zach Sefcovic at the National Weather Service in Cleveland. I've got 10 o'clock, so we'll get started here this morning. Again, welcome to our first virtual climate workshop. Something new, a little bit different that National Weather Service Cleveland is going to be doing. Typically we invite our partners to different things related to severe weather or winter weather or something like that. But with a new decade comes a new opportunity to do something a little bit different. So we're going to do this climate workshop. Today should be a pretty short workshop, 2 hours. We've got myself and then Rayleen Campbell from National Weather Service Cleveland. We'll present information from the National Weather Service side of things when it comes to climate information and resources. But then we also do have some guest presenters as well. We have Bryan from the Midwestern Regional Climate Center out of the University of Illinois, who will give a presentation on different things that the Midwest Regional Climate Center is doing and different resources that they have. And then we have Aaron from the State Climate Office of Ohio at Ohio State University, who will also share what the State Climate Office is doing and perhaps a little bit about climate change across the region. And so hopefully it's a good workshop and you find some important information here. So I'll get it started. Again, why are we doing this workshop? This year being 2021, we completed the last decade. So we have a new batch of monthly, seasonal, and annual normals, climate normals, for all of our climate sites and National Weather Service cooperative observing sites, and we'll talk a little bit about that here. But in addition, we seem to get more and more questions from people like you asking about different climate data and information, and we want to not say that we don't want to talk to you, but give you more tools than calling us or emailing us to have at your arsenal to look up climate information, because there's a lot of ways to get that information out there. And so there's not only National Weather Service resources, but there's other resources as well that we fully support, and you'll hear more about that later. And then, as I said before, it's something different. It's not severe weather, it's not winter weather. I think you've heard from us many times before about these topics, but we are certainly more than just those types of things. We do climate, we do hydrology, we do all sorts of different things. So this is another way that you can interact with us. And so again, I hope today you learn a lot about climate information, not only from us and some of our partners, and what resources are available to you, and we'll go from there. So I'll give the first presentation today, but before that, just some housekeeping. Since it is a virtual webinar, we will hold any and all questions until the end of the presentations. That just makes it easier on our speakers so that we're not interrupting them, and we can hopefully wrap things up as we go through the different presentations. If you do have a question, feel free to type it into the question box. You should have a toolbar on your screen. There should be an area where you can have put in questions. The other option, I believe that should be available to you, is a raise your hand option. If you raise your hand after the presentation, we will unmute you and allow you to talk and speak your mind and ask questions and all sorts of things. The presentations that you hear today should be recorded for any follow-up. So if you missed something today or want to show this to members of your staff, that should be available. We'll also have a list of handouts available after the workshop that we will give you a whole list of links and different resources that we talked about today, in case you missed something or didn't write anything down. So I'll start by giving an overview of the new climate normals. We sent out an email back earlier in May discussing the new climate normals for 1991 to 2020. After we completed the 2010 decade, that allowed for us to create a new set of normals based on the rolling 30-year average. The previous one that we had been using was 1981 to 2010. And the reason why we do this is that we're trying to keep up with needs of different people and users with the changing climate and environment. Certainly as we drop off the 1980s and add in this most recent decade, we have new information that we can add to make the normals more representative for our area. And this also follows, World Meteorological Organization and National Weather Service standards for what climate normals should be for our area. So these normals were released early in May 4th, and they became operational immediately with the National Weather Service with our daily climate reports and our C of6 charts that shows a lot of the information on how it's compared to the past. You may have seen this via an email from us, our webpage, social media, and things like that. And these normals are produced for all NWS climate stations. So that includes our normal climate stations that you may use for larger cities like Cleveland and Erie and Akron, Canton, Toledo, etc. But these also include our cooperative observers. We have other stations, of course, ideally one in every county, if not more. And we have new normals for all of them as well for this time period. And so just a quick glance at what it may have looked like at the beginning of May. This is the Cleveland, Ohio Daily Climate Summary. So you see on our official climate products, you have the normal value and the departure from normal value. And so you see the maximum and minimum and average temperatures, and then precipitation and snowfall. And so you'll see here for Cleveland, especially if you look at the since January 1 for precipitation, and since July 1 for snowfall, you have 11.81 and 68.2 for each of those variables. As we rolled out the new climate normals for these sites, you see that the precipitation jumped to 12.79 for total precipitation expected through May 4th. And then snowfall jumped down to 63.8 inches of snow for the amount of snow for the year to that point. And then the daily maximum, minimum temperatures, average temperatures also changed as well to reflect the new values. And so we have been using this for about a month and a half now with all of our climate products that you may be seeing from us. So the normals, this is a product that the National Centers for Environmental Information, NCEI, generates for us, and they are the official source for all climate normals for U.S. stations. The most important thing that I can tell you about them is that they're not simply averages of here's what happened the last 30 years, and therefore we're just taking the average 30 years of data and calling them normals. They use a technique and that adjusts for stations nearby each other, missing data, of course, incorrectly quality controlled data, things like that may skew values higher or lower based upon what was expected. And so it's not quite an average, although it is very close in many situations, and sometimes it is in the end the average. But normals, of course, we go on a rolling 30-year basis for them. And so since we've gone from the 1981 to 2010 cycle to the 1991 to 2020 cycle, we are keeping 2 decades in the normals that are happening for the area. So we're dropping off the 1980s, we're adding the 2010s, and so since 2/3 of it are the same as the past, that information is not changed incredibly much, but there are changes, and we'll go through those changes here shortly. So what was released early in May were just updates to the normal data for temperature and precipitation, and this includes, again, annual, seasonal, monthly, daily information. This includes things like heating and cooling degree days, growing degree days, snow information, things like that. So a lot of information was baselined with the new 1991 to 2020 normals. However, still to come if you're a more sophisticated user for climate data. There's still gridded normals, ENSO normals, more mapping information that's going to be available as we move throughout the year. Again, at first, a lot of our text products and text information has been updated here early in May, but as we continue here through the summer into the fall, we should be getting more of that information, and everything should be completed by the end of the year. So, with the new normals for Northern Ohio and Northwest Pennsylvania, what's changed? And very simply, average temperatures for the region are higher across the board for that 30-year normal period. The biggest changes you'll see are going to be in the non-spring months. The temperatures in the springtime have increased, but not as dramatically as perhaps the summer, fall, and winter. And then you'll notice some complex changes with precipitation and snow normals across the area. There are some notable changes with precipitation, especially in the early summer and the fall months. And then snow. Snow is an interesting variable. It's most impacted by the 80s falling off and the 2010s being added. But snow is also an interesting variable because it's the one climate item of temperature, precipitation, and snowfall that is most interacted by a human. We have thermometers that read the temperature, and we've got rain gauges of all sorts that record liquid precipitation. And for the most part, those are automated, or it's an easy check manual gauge that has that information. But snow, there are challenges with that and how it's measured, and there's more human impact as to how that's calculated. And so there are some complex changes there, and we'll talk about that shortly. So as I go through just some of the changes in the normal information for our area, here's just some quick abbreviations for our climate sites. We at National Weather Service Cleveland have 6 climate sites that we send out information daily in formal daily climate summaries. And these go out to the public. These go on NOAA Weather Radio. These are available on our webpage. Of course, the key with these are high and low temperatures, precipitation, snowfall, etc. And so for shortness and purposes, we abbreviate these with these identifiers. And so if you see that in the presentation, these are the locations that they are for. All right, so starting with the annual climate normal changes, here are the changes for temperatures, and these are the average high and low temperatures, comparing the old normals of the 1981 to 2020 normal to the new one released in early May of the 1991 to 2020. And so you see that the high and low temperatures for all 6 of our climate sites have increased with the new set of normals across the area. On average, the difference is about 1 degree, although you see Toledo and Akron, Canton are a little bit warmer in the difference between the 2 sets of normals. And these numbers are very similar to trends all across the region, all across the Great Lakes and the Ohio Valley. Again, there's subtle differences between the months, and we'll talk about that shortly. And so this is a map that shows the temperature difference between the 2 decades. And so this is the new set of normals subtracted by the old set of normals. And so for our region, you see that we are warmer with the new set, and that there are pockets that are approaching a mean of 1 for the daily temperature change. For precipitation, our normals have changed as well, and snowfall. You see, for the most part, the rainfall amounts for all of our climate sites have increased, with the exception of Mansfield. There were a couple of seasons where There were just several rainier events, if you will, that impacted the Mid-Ohio region and back in the 1980s. And with the addition of the 2010s and the subtraction of the 1980s, that represented a fairly large difference in the precipitation normal for Mansfield to be changed. But otherwise, generally across the board, the increase in annual precipitation matches pretty well with the rest of the region. As far as snowfall, again, snowfall is a little tricky given that's manual observations, but there are some changes, and you can tell with some of our eastern climate sites in Erie and Youngstown that snow has increased, and I'm sure recent events can tell you that that shouldn't be a surprise. However, in other places, snow has slightly decreased. In Cleveland, there's a more dramatic decrease, and I'll talk about that at the end as to why there's some differences there. And so, noting the annual precipitation change between the two normal sets, you see that we are a percentage wetter than we were with the last set of normals. So what does this have for an impact for our day-to-day climate sets that we sent out? So I actually picked today, for what products that you would have seen last year versus what you would have seen this year. And so you see on the left side are the normal values that we sent out last year. You see that there's several normal high temperatures that are below 80, and then with this year's normal values and what we'll send out later today. Today is our normal 80-degree high temperature for several climate sites. So a little bit sooner on the normals for, say, 80 degrees for several of our climate locations. Precipitation, of course, with complex changes with that. Generally across the board it's higher, but of course there are subtle differences. You see Erie and Toledo have gone down just slightly on the daily precipitation, but again, that's just a function of how things are averaged over the month. So I'll go through these very quick. I broke down all of the climate sites that we operate with the monthly changes just to show the difference between the old set of normals and the new set of normals. And again, things across the board are going to be very similar for all 6 climate sites, but I'll point out some of the more important differences. And so for Cleveland, you see again, with the annual, it shouldn't be a surprise that most of the monthly normals are warmer than they were in the past. There are some subtler changes where the temperatures don't go up as much in, say, the spring months like March and April, and then again in the changing season of the fall in November. And so that just has to do with some variability there. For the snowfall, you see where we've added and subtracted snowfall amounts, so a little bit less on the early season, a little bit less than the late season for snowfall. That reflects current data. So you're going to see many of the similar trends for Akron-Canton, warmer across the board for all of the months. Precipitation, certainly there are some increases and decreases, and Akron-Canton's a great representative for how precipitation has increased in, say, the early summer. We're adding a ½ inch of precipitation in June, and then another ½ inch of precipitation in October. This seems to be the trend across the region where we do have a little bit more precipitation in those months than we have in the past. And so you'll see this in several of our climate sites moving forward. Erie follows similar trends where not as warm in the spring months, and then again we have a jump in the fall of precipitation. The one important thing to note, and I'll talk about this towards the end of my presentation, is that while Erie did get a significant snowfall in December of 2017, the normal value for snow for the month of December has actually decreased across the region. We'll get into the nuances there, even though they did have a significant event and how that was handled with the climate normals. And then continuing on, Mansfield, again, warmer across the board, complex changes in precipitation and snow across the area. And the same goes for Toledo. And finally, Youngstown. And Youngstown is one of those sites where there were perhaps a little bit more pronounced muting of how much increase in temperature there was during the late winter, early spring months. And you can see that with some of the lower values in February, March, and April. So not to bore you with charts all day and things like that, but again, a lot of these trends are going up with temperatures going up are much as expected and much similar to what's going on with regional trends in the data. Again, precipitation data is a little bit more complex to explain, and the focus should be more on not necessarily how much is going down, up or down each month, but we're talking about rain and snow days and how those are down, yet precipitation remains generally the same. So we're getting more and more significant rain and snow events in a single day. And again, these data sets weren't made just by using the average values over a 30-year period, but rather these values were created using a larger data set, understanding the trends in the region and nearby climate sites, and adjusting for things where manual error or poor quality control may have resulted in some issues. And this is probably mostly done for our snowfall information. So two of the questions that I'm sure folks may have seen with some of the information I presented are the snow changes. So I'll talk first about Cleveland. Cleveland snowfall was probably the most eye-popping change for the new normals. The annual snowfall for Cleveland decreases 4.3 inches. And the best way that I can explain this to you is this is a large impact from the 1980s being dropped off and the 2010s being added. So the chart on the right there shows some quick statistics on the top 5 snow years for each decade and the mean for each decade. And so you see that the 80s were very consistently snowy, and the 2010s were very variable in the amount of snowfall that occurred. And so while the 2010s, 2014 had the most snowfall for the actual year, the fact is that it quickly dwindles as you go through the top 5 for each decade. In addition, I put some quick statistics on the left as far as number of days with certain amounts of snow. And so the 1980s had several events where there was 5+ inches of snow 20 days, and 11 days with 7+ inches of snow. And the 2010s were significantly less in both of those factors, which just adds to why Cleveland snowfall decreased. It, again, mostly a function of the 1980s falling off, the 2010s being added. As far as Erie, again, I pointed out, December snowfall is down, even though there was a significant event around Christmas in 2017. And so the 2017 value you see on the right is 93.8 inches for the month of December 2017. Yet, in the end, the new normal for Erie for December is down. And so I quickly did a mean calculation for the 30-year period. You see it's 26.1, and the new official normal is 26.3 inches of snow for Erie. So what's going on? Well, again, somewhat of a function of the 1980s falling off and the 2010s being added, much like Cleveland. You see that the mean for the 1980s was 28.7 inches of snow. And there were a lot more consistent snowfall seasons, with only 2 seasons being below 10 inches of snow, each of them being 8 and 8.9 inches. Whereas on the right, 2011 through 2020, much more variability in the amount of snowfall that we have in Erie. So while there was a significant event in 2017, there were 4 years where December had less than 10 inches of snow. And so going from a spectrum of 4.9 inches to 93.8 inches, in the end, the mean ended up washing out that extreme number, and the amount of snow for December for the normal went down for the region. So wrapping it up here, and then I'll take some questions. So these new normals will be in place until 2031. So if you are anxiously awaiting the next ones, you've got 10 years to do so. So enjoy waiting. In the meantime, we'll be posting all of our climate products and services using these new normals, and anything that you see compared to normal or based on normal will be on these values. And then, of course, as I said before, there's going to be additional information that will roll out through the rest of 2021, including some of the gridded data and more mapping data and ENSO data and things like that. So if you're a more sophisticated user of climate data, that will be available to you in the coming months. And so with that, that does it for my presentation. And so I'll see if there are any questions here in the queue. And I'll see if there are any hands raised. Okay. And again, I will share these presentations with all of you if you wanted to see something more specifically. And again, you know, climate data and charts and things like that certainly can be something to look at 10-something in the morning. I see we've got one hand raised, I think. Is that Dan Stahl there? Let me unmute you, Dan. All right, Dan, I've unmuted you. You got a question for us?
Morning, Zach. I just wanted to make a comment. Thank you much for putting this on. That was pretty informative.
No problem. Oh, did we lose you, Dan?
I'm right here.
Okay, you got a question?
No, I didn't have a question. I just wanted to thank you for putting it on, Zach.
Oh, well, thank you, Dan. Much appreciated. Hopefully, the other presentations are much more interesting. I promise everybody that. So,
very good. Thank you.
Yep. All right. Any other hands raised or questions in the queue? All right. Well, with that, I'm going to pass to our next presenter, Rayleen Campbell. She's another meteorologist and climate focal point along with myself here at National Weather Service Cleveland. And so let me make her the presenter here.
Can you see my screen, Zach?
I can see your screen, so you are ready to go.
Okay. Oh, I gotta get rid of. Okay. As Zach had said, my name is Rayleen Campbell. I'm also a forecaster here at NWS Cleveland, and co-climate focal point along with him. So today he explicitly asked me to talk about local climate resources and where you guys as the public and as partners can access climate data, since some of the sources aren't as straightforward, or I guess more or less people just aren't aware that they exist. So before I jump into that, I wanted to touch briefly on the history of the climate sites, purely because we receive a lot of questions about how our climate sites have such long data ranges when a couple of them, well, most of them have all moved slightly throughout time. So just to give you an idea, this is a map of our area that we cover. So we're pretty much Toledo up through Erie, PA, and then down to Canton and Mansfield. So just to kind of give you an idea through the presentation. So this is like a lot of words on one slide, which I typically hate doing, but for the sake of this presentation, I really wanted to show how, even though everything does, all the sites slightly have changed, whether it be to, or as a result of urbanization, such as in Cleveland, or the result of just kind of switching overall locations in terms of maintenance. So really the only one that has stayed where it started is at Youngstown. Youngstown stayed at Youngstown Regional Airport. And pretty much going back as far as you can go with each of these climate sites, you have temperature, high and lows from that starting point through present time. It gets a little bit more finicky with precipitation and snowfall. Snowfall became more abundantly available as people began taking good descriptions and good measurements of snowfall more in the 1900s compared to back in the 1800s. And precipitation, again, it wasn't far behind temperature, but those also have a different time range. So that's just to kind of give you guys an idea of where all the data for our specific climate sites come from. So at the Weather Service, where do we get our climate data? How do we make our climate, where does any of this data actually come from? The first and foremost state or entity is ASOSs and AWOSs across the area. So those are automated surface observing systems and automated weather observing systems. And that is, AWOSs are typically at airports, but vary, again, across the country and across our region. Then we also have co-op stations. Co-op is cooperative observers, and they essentially each day measure precipitation, temperature, etc., and then it goes into our system, along with the COCO-ROS observers. I'm sure many of you have heard of that. And then and NWS Cleveland, we also have the marine observations that go in from either buoys and or the lighthouses. So we get all this data every day in the morning, and then at NWS Cleveland, we go through and we QC all this data before we send the products. So there is a middleman to observing and ensuring that the data quality is there. Because sometimes, it's easy to do a simple typo. So that's kind of what we're here for, to ensure this good climate database exists. So jumping to a local site is just simply our NWS Cleveland Climate webpage. So if you go to weather.gov/CLE, which is just the local homepage, and you scroll down, there's a bunch of buttons that you can click that take you to various aspects of weather and of our office, one of which is climate. So when you click on climate, you get what we call the local climate matrix. And this essentially is a data dump of records, normals, our daily products that we send out. As Zach had mentioned, there's like the F6 and things of that nature. Everything gets dumped into here. So I'm going to actually jump to that webpage real quick. So in this matrix, everything is updated as needed or at the end of the month. So I say as needed primarily for holiday information. Holidays are updated after the holiday occurs, and it gives the most up-to-date information for each individual climate site, along with some nice graphs and things. So I'll just click on this to give you guys a quick example. So if we do New Year's Day, if it will load, there we go. So as you can see, I make sure that I put the date that it was updated by at the top, and then you have all of your information. So you have your period of record that it's referencing, and then the average along with record highs and lows, and some nice graphs that we make. So these are free for you to use for all 6 climate sites and to reference. And then all the raw data, so if you see you were looking for a specific year, what was the high in 2015, that specific information can also be found at the bottom. So jumping back, okay, there we go. Jumping back, as I had said, all this information is routinely updated. At the end of every month, I go through and I update the daily and monthly records and other climate informations, and then at the end of each season, I also update those. At the top, I update the top 10 annual records after the year has ended. Also, with the holiday climatologies, I try to keep those as current. Normals have all been updated on our web pages. I appreciate, we've gotten a couple feedbacks from people just on simple typos that I made, so I definitely appreciate that. Then we also have frost freeze information for anybody who's more or less agriculturally focused, but it's used for a lot of different aspects. We also have past season snowfall information, which gives you a synopsis of essentially what the season looked like for that year. And then we also have first and last snow along with the season length for each site. So now jumping, this is another tool that you can use off of our web page. It's called NOAA Online Weather Data, or Now Data. So Now Data is essentially a query system that allows you guys to access basic climate statistics in a one-stop tool. So you're not going to have to keep jumping back and forth between a bunch of different, databases or web pages. It's a one-stop shop where everything is. The data in the system contains data from over 3,800 surface observing systems, but that's across the country. And it contains quite a few from our local area as well. And it spans outside of just our normal climate sites, 6 climate sites. So you will get some of the AWOSs and things of that nature in there. And also, in addition to that, it spans back from the 19th century all the way up to yesterday. So it really gives you real-time information or archived information, depending what you're looking for. This program is maintained jointly by NCEI and the regional climate centers across the country. And it's important to note that all the data is based on archived, which is obviously the stuff in the past, and preliminary data across NOAA. So preliminary is more for the data in recent years, because before any data, we send out data and then it has to be verified and made official by NCEI. So if you're looking solely for official data, you have to go to NCEI, which I do have a slide on that here in a bit. So this is what it looks like. I'll actually jump to that web page. But essentially what you do is you click on our, off of our homepage, it has a climate button. So you click that, it brings you to the upper left-hand screen. That gives you access to essentially all of our current climate products, past climate products, regional climate products, the list goes on. And it's archived, I believe, back till about 2016. But to get more information, if you go all the way to the right, it says Now Data. And if you click on that, the Now Data screen in the lower right-hand corner, that's what you'll see. So as I said, it gives you more than just the basic climate sites. You can see our Akron through Youngstown, but then you also have Chippewa Lake, you have Cleveland Hopkins, various other things that are just specific for certain sites. So let me jump to that just so you guys can kind of see how user-friendly it is. So here, if we do Akron area is going to be the official site, or the official climate site. We'll do daily data for a month, so that's going to look at all the data from last month, so the month of May of 2021. And when you click it, it gives you a very user-friendly graph of, the high and the low for May 1st, 2021. It's departure from the normal, how much precip and snow depth, etc. And you're able to print this information off really easy. You also can click on these titles. So if you want to see the warmest day of the month, you just click on maximum, and we had 2 88-degree days in Akron. So really user-friendly, and it's a quick, easy way to get some climate information that you're looking for without having to dig too far. So jumping from now data, the bigger source across the Weather Service is the Climate Prediction Center. And they're the ones that provide the extended long range and monthly outlooks of temperature, precip, and hazards. So for example, if you look to the right, we have the 8 to 14 day outlook for temperature and the 8 to 14 day outlook for precip. These are not current. This is valid from May 21st through the 27th. I made this presentation a couple weeks ago, so that was up to date then. But in addition to these, it also provides information about teleconnection patterns, which is your El Nino, La Nina, etc. And it gives links and additional information on U.S. drought, along with an absurd long list of other products that can help you out. And it's really user-friendly and does a good job at explaining what some of these things mean. So the next place that you can go and get climate data, and more specifically where you can go get official climate data, is the National Center for Environmental Information, or NCEI. This is the entity that hosts public access to one of the most significant archives in environmental data. So literally, it is the center of archive data for the U.S., along with the center of making data official before being sent out to the public and things such as the normals. This website contains, again, a whole slew of products. You have the official storm database. This is very useful if you're looking for a specific storm that had occurred, or if you're trying to figure out how many tornadoes occurred in one specific county. You can go based off of event, time period, the list goes on. So it's really user-friendly, and you can query however much data you want out of that. And it just drops it into an Excel sheet, and then you can kind of do what you want with it from there. It also, NCEI also provides a ton of educational toolkits and references. So kind of like this presentation is doing with providing you guys resource references. If you go to NCEI, they give you a lot of educational tips and tools in terms of climate and even weather data. It also hosts Esri story maps created by NOAA offices. So Esri story maps are essentially GIS-driven maps that are interactive, and a lot of them take you through historic events that had occurred or even more recent events that occurred. So those are also hosted on their website. It also taps into global climate information and space weather information. But as I said, the list goes on and on. So I encourage everybody to go check it out. Pretty much anything you could look or could need is likely there. And if you guys can't find it, just reach out to me or Zach, and we would be able to help you out there. So moving on to the regional climate centers. The first one is the Midwest Regional Climate Center. That's hosted out of University of Illinois, as Zach had mentioned. It covers primarily Ohio, but does extend to cover Northwest PA for our 2 Pennsylvania counties. And more importantly, this is the host of the Climate Online Data Portal. I'm not going to dive too far into any of this because Bryan Peake's talk later should touch on a lot of this, and I'd rather you hear straight from him, somebody who works there, compared to myself. But we can't forget about Northwest PA, so the Northeast Regional Climate Center, hosted out of Cornell University, also covers those Northwest counties. Examples of products that they have include the climate normal maps, various analyses for industries ranging from heating degree days, ways to apply frost risk, things like mosquito control. The list goes on. They provide quite a few different products that could be useful depending what you're looking for. It also provides weather station data and daily almanacs. So if you're looking, this is more, the Northeast Regional Climate is going to focus more on Pennsylvania versus Ohio. And the Midwest is going to focus more on Ohio versus Pennsylvania. So just kind of keep that in mind, depending where you are in terms of our CWA. And last but not least, we have our state climate offices. And with our state climate offices, we have the one in Pennsylvania for our 2 Northwest PA counties. And then we also have one hosted here in Ohio. So looking specifically at the Penn State office, the state climatologist is Kyle Imhoff. And at their office, specifically on the office website, they include weather summaries, various climatologies from hourly to daily to monthly, etc. And they have FROST program, which stands for Frost, Rain, Optics, Snow, and Thunder. And as I said, they are hosted at Penn State University. And then in Ohio, we have the State Climate Office of Ohio, or as we abbreviate, since we abbreviate everything, SCOO. And the state climatologist is Dr. Bryan Mark. This office specializes in agricultural climate resources, polar climate research, and other research. But I'm not going to, again, not dive too far and take too much of Aaron's thunder, since he will be talking more about this later. But again, that is hosted by the Ohio State University. So with that, I will take any questions. That was definitely kind of just a crash course of different resources you guys can use. And as Zach said, these presentations will be provided to you. So that should give you a nice resource background to kind of browse some of these resources yourself. Any questions?
Thanks, Raelene. Wonderful presentation there. I'll take a look, see if there's any questions in the queue or any hands raised. Running a bit ahead of schedule, which is a rarity for me, I will say. I don't see anything. Any questions? All right. Well, thank you, Raelene. Much appreciated for your time putting together this presentation. And again, for anybody listening, we will have this recorded, and we will send out links to you in case you did not have access to some of these earlier. We'll make sure that you get a copy of these links so that you can use them for anything that you see fit. So with that, I'm going to switch to our next presenter. Let's do that. All right, and our next presenter is Bryan. Bryan Peake, he is one of the climatologists at the Midwest Regional Climate Center out of the University of Illinois in Urbana-Champaign. And he's going to give us an overview of the Midwest Regional Climate Center, who they are, what they do, a little overview of their climate program, which is fantastic and another great resource that you can use to look at climate information. And with that, I already see he's sharing his screen, so you can take it away, Bryan.
Good morning, everybody. Thanks for coming and taking a quick look here at different climate tools that are available. I apologize in advance for my dogs who might be a little bit playful this morning. So if you hear that in the background, I'm going to try to get them to finally take a nap. First of all, this is our MRCC's homepage. Basically, we have a lot of information that can be used in a lot of different ways, not just for the Midwest. Oftentimes, our tools are national in scope, or at least more than just the Midwest region. Sometimes we'll cover Central region as well. So the first thing, of course, I'm just going to help you find where climate is, because climate is our biggest tool. It's the most requested place to go on our website, because that's basically where you can find any data from daily or hourly stations now. So we have a quick link here on the right-hand side of our page. Climate, it stands for MRCC Applications Tool Environment. That's the MATE in it. We also have it available under Data and Services in the top bar of our page. So clicking on that, of course, it's going to be free to use, like all of the products on our website. And you just create a quick login and password. It doesn't matter too much. It's more or less just for NCEI housekeeping. And then once you log in, you'll show up on our landing page. A couple things to notice at first. We do have both your daily station and hourly station up at the top of the page. If you need to change that, you can easily do that by clicking on Select Daily Station or Select Hourly Station. For this example, I'm just going to go to Daily Station. We have a map selector, so if you don't know exactly what the closest station is to, say, a rural area in your CWA, that's kind of the best way to find that. If you know the station ID right offhand, so like KCLE, for example, you can put that in there and it will find that station for you right there for the Hopkins International Airport. And you can also find a station by state, climate division, or even just by county. So in Ohio, you could pretty much find any station you could think of just by doing that. I'll just put Huron for an example, and then it will show all the stations in that CWA, or sorry, in that county. So, and whether or not they're current or when their period of record ended. So those are all there. For this example, I'm just going to go ahead and put in KCLE. And of course, you're going to go, once you have that, you click on Go. Before that, though, I'm going to click on More Info. And this is a great spot to find out the metadata of that station. So you get the county, the state, the climate division, all of the associated IDs with that station. But you also get this period of record over here on the top right-hand side. So you get the different variables that it has. And then if you click on See Station Inventory, this is actually one of the cooler parts because it lists when there's actually data. So Cleveland's a great station because obviously it's been reporting pretty much nonstop. But if there has been any gaps in the data, because a period's start and end date might show some stations that had some missing data for a while, this is a great way to find out where that missing data is. So if you're looking, say, just for the 80s and that station didn't report in the 80s, it reported before and after, this is a great way to find out. So obviously Cleveland Hopkins is a great station. You shouldn't have any issues with missing data there. So I'm going to just go ahead and click Go. And with the daily observation data, so we'll start off with the daily. We have a lot of tools. There's your typical straightforward daily between two dates. So this is an example of you just want the data for a period. So the data for this month, here's the daily data observed for this past month. What's great about this tool and a lot of the tools on our website, we have a CSV version or a printer version. And you can click on the CSV version to get a download that you can just straightforward put into Excel and use that to make graphs as well. We also have a way that you can just plot the climate data straight from the web page. So if we click on plot climate data here, you can get the daily high and low temperatures and precipitation, and if there is snowfall and snow depth, of course, it would show there as well. So we have those all available just straight from the website, and you can download that graphs straight from the website as well. So these are all cool tools. You can even zoom in on specific areas, as I just did there, and then reset it back to the period that you have. So these are all really cool options, and that's just the first tool. Because under daily, we have things like degree days. That's something that you don't always find, and it's customizable. So if you want to do a growing degree day for some agricultural purposes. 50 isn't always what you need. Oftentimes 50 is more for corn, so it could be it could be 45, it could be 42. You can easily just put that in, and you can change an accumulation date if you wanted to start on March 1st, March 15th, any date of the year, basically, you can start from that, and it will get the tabular data and do that degree days accumulation since a certain time of the year. So this is a really great tool that we worked on just when I started here, probably in 2014, 2015. That's really evolved since then. And we've added things like freezing degree days for lakes, for understanding how a lot of times I think when we did that, it was more like with the lakes in Wisconsin that we were actually working with at that time, that they were using freezing degree days for that. So we added that in as well. So that might actually have some applications for the Great Lakes as well. Some other daily tools, this date in history. This one also has the holidays. So if you wanted to find out what the holidays for a bunch of different holidays for years, including things that aren't on every day of the year. We even have Indianapolis 500, Kentucky Derby, things like that that might be more regional. So those are all available under this date in history. There's things like a threshold search. I think this is one of the cooler products that we have. So if you wanted to just see days that are greater than 90 for a maximum temperature, and if you want to get the chronological list of dates, in this example, I'll do monthly counts, where basically you can find the number of days where this is common and happens. And you can kind of do like a small climatology from that standpoint of the days that are above certain thresholds or below certain thresholds. So obviously we've just started through June here, so there's no data for July and beyond. But if you look at the averages, you can say for in general maybe 5.5 days per year over the past decade or so. That there's been 90-degree days in July at the Hopkins Airport. So this is a great way to find some of that more specific data. And we often use this for people who have these questions of what are the extremes in certain locations. Another interesting tool is multi-day extremes. So let's say you need to know what's the highest average or the highest precipitation amount over a 3-day period, especially when it comes to flooding. This is a way to do that, and it will give you, say, the number of events that you want. So if you wanted 20 events shown, it will do that. And then if you want it during a certain period of a year, so if you just wanted the spring months, you can do March through May, just to get that data. And if it will run here quickly, it will. Then you can get that value. So over the past 12 years, 10 to 12 years, I think May 14th through 16th was the, and of course these can contain days that are before and after. So 3.28 inches for that 3-day total is the highest. So these are all options again. You can do a daily ranking. You can do monthly rankings and seasonal and annual rankings as well. That's one tool that's throughout all of these. You have things like single variable data. I think this is one of the cooler ones as well because you can add in the normal for that day. You can also do a running accumulation for that period that you have selected, departures, and the time of observation. So like 7 a.m. is common, midnight is common for the ASOS sites. So those are all options, and it looks like it wasn't pulling data for that, so I'll have to check in with that. Some other cool tools, multi-station. So if you wanted to just find the precipitation for a certain climate division in your state, this is a way to do that. you can just select, say, Climate Division 2 in Ohio, and then it will spit out basically all of the values for that area, including the CoCoRaHS stations. You can sort these as well. That's kind of the coolest thing about this. I use this often to get extreme values for reports. So you can find precipitation amounts, and that's the highest precipitation amount over that 15-day period. Here is at the Bascom CoCoRaHS site. You can find 1-day maximum values, so that's 2.38 inches. You can find snowfall. You can find a bunch of different information points for pretty much any area in a state or a region or a climate division. And then just going to move on here. There's a lot of other things. One thing I want to just straightforward let you know, I'm not going to be able to cover everything today, but we do have a help page. We have a product guide, and then we have a product guide specifically for National Weather Service users that kind of tells you about what you can find on climate that you might not be able to find on XMASIS. So these product guides, they're just Word documents we have in PDF format that gives you a understanding of what each does. So daily data, monthly data, the seasonal data, as I was trying to quickly go over here. And then we also have the multi-station data. We'll next get into the hourly observed data, the state and climate division data, and the maps of data. So basically, if I can't get through everything, and I probably won't, this is the best way to get that information is to basically go to this help menu, and we have those product guides. The video tutorials might be a little outdated, so just a heads up there. So I'm going to move on here to the hourly data, and the hourly data, it's very similar from the daily data when it comes to the station selection. There's just fewer stations because they're just mostly the ASOS and AWOS stations. So I'll go ahead and put in KCLE again for the station ID and click go. One of the things to note, again, you have that more info button. We don't have as much information beyond just the period of record. At this point, it's a little bit harder to go in and get the kind of the station inventory that you get with the daily data. So now that it's selected as our current hourly station at the top, we can look at a bunch of different options here under hourly observed data. And these data all come from NCEI. We worked with the Midwestern Regional Climate Center for a while to put together a database called CLIDAP. And it's got web services that you can just pull the data at will as well. And I can go into that if anyone has any questions through an email or contact later. Sub-daily is where you're going to get the actual data. Just if you need the raw data, you can go to the sub-daily data lister. And here it's auto put to just the last couple of days. You can always change that, of course, to the last 7 or this month. The one thing I'll caution is that if you try to pull the entire period of record, it's not really from our end that's the issue. It's just the web page itself can't process all that data on to be listed. So it might be best to bring that into 30-year increments or less. Sometimes 20 or 10 will be more likely to get all of that data. You can select just individual types of values. And you can also put in wind chill and heat index. Just for this example, I'm just going to select all. We'll get tabular data here quickly. And basically, you'll be able to get temperature, relative humidity, which you're not going to get with hourly or with daily stations. Same with dew point, wind speed, and wind direction, and wind gust. Those were very important when I put together a wind chill and heat index climatology that you can't just do with daily data. Things like cloud height are also there, visibility, pressure. The one thing I will say though, with precipitation, we have a lowercase m in a lot of these spots, as you'll see here. What those mean isn't that the data is missing per se. It's more or less that the data, there was no observation. So if you ever look at official ASOS, AWOS data, a lot of times it will just be a blank area for precip if there wasn't rainfall. But if there is rainfall, then they'll say 0.01 or 0.01 or whatever it is for that hour. So that doesn't mean that there is no data there. It just means there was the absence of an observation. It can be a little confusing with that. Moving on, a couple of other options. We also have a threshold search. So if you wanted to find things like heat index, wind chill, precipitation, wind direction, all of those things are available to be searched by certain thresholds. So if we wanted relative humidity or dew points above 70 degrees, that would be one thing that would be somewhat interesting. And we do that over a 5-year period. Just for this example, I'm not going to actually go to the output, but you can do this for a bunch of different options. So you can do it for just list me the hours that it's happened. You can just list the days. You can do monthly counts by the hour of the day. So if you wanted to see if it was in the afternoon or if it was in the mornings, and then run of hours. So if you wanted to see just when there's been 3 hours in a row that it's met a threshold. So those are all options. There's a lot of options. There's a lot of different types of data that you can find. So it's basically unlimited to what you can think you can find. So, and then also there's daily data. So these are basically summarized from the hourly data. You can find what the average values are. So I'll just pull this up here quickly. And you can get maximum values as well. So maximum dew point, maximum temperatures, minimum temperatures. And again, these aren't actually what the high or low for the day is. It's what the highest hourly value was. So there is difference between that and what an official high or low for the day is. So it's just more or less it's there for things that aren't really given as a high or low temperature value for an official record. So things like wind direction, what the mean wind direction was for a day, or the mean wind speed. So those are some interesting things as well. You can also get daily summaries of different stations. So if you wanted all the stations in Ohio for a given 7-day period, you can get that as well. There's a couple of values here. We'll see if it can load here in a reasonable time. You can get the mean values, the max values, dew point values, all of those different variables, and you can again sort them using the sorting tools at the top of each of these pages. And you can also download it. Like I said before, a lot of these pages, they'll if you look at the left-hand side, you'll have a CSV version as well. And then finally, there's a couple other tools. Frequency distribution, it's fairly similar to threshold search. It does take quite a while to run this, but basically you can say what's the frequency of having a temperature between 88 and 90 degrees over a certain period, and you can do it by either the hour or by the month. Again, there's a lot of data that you can go through with this just to decide, you know, the commonality of certain things with the certain stations. And then the one thing that I do want to go over, the Windrows. This is very often used by energy companies, and I get quite a few questions about Windrowses. Basically, you can get any period and any time. So like say we wanted to just see over the past 3 or 4 years what the spring wind might be from. This is obviously very common very interesting to see in Chicago when you have a lake breeze coming in off of Lake Michigan. We'll just see what we can find here with March through May over the past 3 years here in the Cleveland area. And basically it will just give you a percentage values for each direction that the wind goes into. And this is in a 10-degree interval. So you'll see different areas that are more common. So from the north-northeast, that's where the wind direction is the most common during that period. And again, this is for that 3-year period. And then the southwest to the south is probably the secondary wind direction. And what's interesting too is it'll give you a full table at the bottom as well, along with average wind speeds, the total percentage points that are in each category. You can actually change this as well in the output to find just instances versus values. And then, of course, what's important here is it tells you how many observations are actually in it out of the possible. So there's a few missing hours, but it's a fairly robust amount of hours that are in that smaller climatology. And again, you can download that, the data itself, and you can also download the chart itself by clicking over here, and it's a lot of different image options that you can do to download that for any type of presentation or just for general understanding. So that's hourly observed data. I'm going to quickly go over the next options. Climate division data and state data, they're basically the same. It's just that some people are more akin to the climate division versus looking at states. But basically you can look at all of the NClimeDiv data products through this. So if I just wanted to look at the state monthly by year for Ohio, that can be done here for, and we'll just do 2012 to 2021, and you can get, here's the precipitation values for the state of Ohio for that period of years. And then you can also see the normals are available at the bottom, so you can compare those. We also have a way that you can rank states, rank the data for a period of record. So often we'll just have this put for the full period of record, but you can also just do it for a subset of 30 or 50 years if you wanted to. And if we wanted to just do January through May or January through April, that's also an option. You can do precipitation, temperature, maximum and minimum temperature are now available there as well, along with heating and cooling degree days, drought indexes. Those are all available here to be ranked. So if we'll just do temperature, then you can see what the hottest and coldest January through April periods are over the periods of record. A couple other options. You can do a chronological listing. You can do a snapshot of different months for a different region. Just so if we just want to take a look at a snapshot of Ohio here over May 2021, you can look at the different climate divisions here for Ohio and the statewide values. This is just for May. And just to see what the departures and the normals and everything are for that period. So that's kind of an easy overview if you wanted that as well. And the next thing I'll do is I'll just move on to gridded data and maps of data. These are pretty much the areas that if you wanted to pull up a map for someone, that you can easily do that. So I'm going to pull up a map of gridded data for a specific period. These are the easiest, the quickest maps that if you need something generated quickly just to see what a certain period looks like, this is the one for you. So I'm just going to quickly go through January through February 28th. So because I don't remember what that 2-month period looked like, and we'll do a percent of mean for precipitation. and see what it was like in certain areas. So it was between 50 and 75% of normal across most of the Lake Erie lakefront during that 2-month period. So that's a way that you can quickly do that. We have it defaulted for the Midwest region here, but you can also do that by state. So if we wanted to just do Ohio, we can do that and just see state of Ohio kind of zoomed in. And you can also do that by climate division, or not climate division, by CWA. So if you want to do this just for the Ohio Cleveland office, you can draw the outline as well for your office so that you can see what it looks like for that area. So it'll include those counties in Pennsylvania as well. Now, these aren't the highest when it comes to resolution. The higher resolution maps are actually under interpolated station data, which is under maps of data. So this is very interesting. Basically, it's taking the data from climate that we're using through ACIS, which is the web services tool. And then basically you can get a map that's very detailed, very decently high resolution of 5 kilometers for basically any period that you need. Now, the problem with this is that it does take a little bit longer to run, but it does have a lot more options. You can put interstates in them, in the maps. If it's a state or a CWA area, you can put station locations as well, or city areas. If it's just a state, you can mask out the state so that it won't show areas surrounding the state. So I'll just do that here quickly. And these options make it more appealing, and they're often more valuable from that standpoint because they actually show that higher resolution where you might not get that on the other values. So this is average temperature, and from this past 15-day period, it's pretty much been homogeneous throughout the state of Ohio. So that's a very interesting. This is probably the best mapping tool we have available because it is customized. You can do it for any period of time or location. It's probably one thing that I love to use the most, simply because you can come up with any map that you can think of on the fly. So that's that's probably my favorite tool on climate. But another thing that might be useful because of the Great Lakes, we have this binational precipitation maps. So what these do is they aggregate the MPE data set that's from the US and the CAPA data set from the Canadians. And it can put them together as a way to better understand precipitation in the Great Lakes area. Now, these do take a long time to run, so they're not going to be shown specifically on the web page. You'll actually get an email with the output once they're finished. But these are very good when you're looking at data that could impact areas not just in the US, but in Canada, where the mapping is a little bit harder to do from just the US data. So I just wanted to point that out as well. And that's pretty much it for climate. Again, like I said before, if you have any questions, you can always ask me, of course, but we also have this product guide and the product guide for the National Weather Service. So that can find you the tool that you're looking for based off of the questions you have. Again, this is just part of what we have on the MRCC website. As I'll quickly go to our homepage here, we have a lot more available. We have the Midwest Climate Watch. We have the useful to usable tools as well. The vegetation impact programs, where you can find the freeze data and freeze climatologies as well. And we also have, just to kind of shamelessly plug my baby, I guess you could say, my heat index and wind chill climatology that I've really undertook over the past few years, that you can find the heat index and wind chill climatologies for stations throughout basically the entire U.S. at this point, as we've given the data to NOAA as well. NCEI was really akin to getting that data. So we have a lot of different tools under Midwest Climate and Resources, a lot of informational tools as well, if it's beyond just the scope of just what the data says. Again, if you have any questions, feel free to contact me. I'm going to put up this slide here though quickly. The MRCC is moving. The contract has been awarded to Purdue University, and we are currently in the transition period from the University of Illinois to Purdue University. So there is a new website that will be incoming. So if you have bookmarks for the MRCC, those will be changing here in the coming weeks. We are anticipating that by the end of June, that a good chunk of the MRCC will be fully transitioned, but we will keep the website up at Illinois until further notice, until there's basically that we can transition smoothly to Purdue. So a new website is incoming. We anticipate it to be mrcc.purdue.edu, and we also expect the email to be similar to the MRCC's current email of mrcc@purdue.edu would be the new email. At this point, there's no anticipation that I personally will be with the MRCC after this transition, but you are always free to contact me at bpeake@illinois.edu. I'll still be at the University of Illinois, at least throughout the transition. If you have any questions, feel free to contact me even after the transition, because I do have quite a bit of familiarity with the MRCC's tools, even if I'm not going to be working with them. So with that, I will leave it at that. And if you have any questions, I am more than open to answering them. Thank you.
Bryan, thank you so much for the overview of everything going on with the MRCC and the climate program. Just before any questions pop in here, just to clarify, if people want to use the climate program, they need to get an account. That is correct?
That is correct. So when you click on the climate link, there will be a thing at the top right-hand side that says new to climate. And if you go to register here, then you'll be able to put in the information, and you will get an email that says that you've officially gotten into the system, just so that you have that security of knowing you did it correctly. So you do have to create an account, but it is completely free.
Thank you for clarifying that. Yeah, and again, you know, everything that Bryan showed you is fantastic. You know, there's a lot of utility to the climate database, and I know us at the National Weather Service in Cleveland, we use the information often, especially when we're answering questions that you guys may ask us regarding, you know, previous climatology to the past, and even, you know, some of the sub-hourly information. It's a great resource that you can take a look at various things. And, you know, Bryan's walkthrough was excellent, and just, you know, seeing all this information. So I highly encourage you, if you're interested in climate data, to sign up and get a climate account and take a look at everything that he showed you today, because it's really a great resource. I see one hand raised. I think Bob, our Science and Operations Officer. Let me unmute you there. All right.
Okay. Hello there, Bryan and everyone else. I have a question about growing degree days. We had our spring, it warmed up quickly in March, and we had a really hard freeze like April 2nd. And now I may be wrong here, because I'm not super familiar with your site, but your freeze map showed like the growing degree days from the last freeze. So what happened is after April 2nd, like all the counters, the degree days got zeroed out. And
Right.
And you just showed in your example how I could reset the count or determine the growing degree days from any particular date. Now that's great for one point, but are there maps that could show me like the growing degree days from, March going forward in time? So if I had a freeze in mid-April, I wouldn't have all the counters zeroed out, because we were trying to ascertain how far is the vegetation along by the growing degree days. And since the counter got zeroed out on April 2nd this year, we didn't have any more maps. Now, unless you do have maps somewhere on your site that would have shown the accumulated numbers maybe as the spring is progressing, with or without freezes, without the freezes.
Right. So I know for sure we have we have two different options for growing degree day maps that we have under, and if you're still seeing my screen, this is under the Midwest Climate Watch under maps and images. It's kind of with the landing page, but it's towards the bottom. There's this seasonal maps that have modified growing degree days. So we have maps of those. We don't really have anything on climate per se that you can create a map on the fly with that. But these maps, they start on the April 1st, and we also have one that starts on May 1st. These are not zeroed out. So basically you do get all those growing degree days for that period. They are just for the Midwest region. They're not really something you can narrow down by state. But these do not reset. They don't go back to zero if there's a freeze. So that's one way to do that.
Now the resolution there, I mean, with that scale, let's say in April when things are just getting started, I mean, your scale's up to 1200 degrees.
Right.
Would the scale be, the higher res when we want to look at the first 400 degree days, as the season, as it's budding out? Would that scale change?
Yeah, so the scale definitely does change based off of the period. So because this is, we're in mid-June now.
Yeah.
The scale's a lot larger than it would be before. But there's basically it does change depending on the time of year or so.
Okay, but it's actually just every month though. So I would have to look. So if I was in that April situation, I'd be looking at the March 1st through that date, I guess, probably. And that.
Yeah, and the issue is because we don't really have a map that starts on March 1st. That's something where you'd have to probably go to the individual station. And here for example, I did through January 1st. So we have the accumulation starting on January 1st, and here's the value since then. So, there was that warm enough period there where it was getting to the 60, 70 range. And then you had that freeze there in early May or early April at 74. So it will continue to keep going up and up just based off of that. So 74, and then it went back into its accumulation. So it's really a station by station thing for more of those custom areas. Don't really have a mapping tool for that at this point.
Yeah, okay, because I know that the offices, we try to coordinate for the frost freeze program in the spring, and I know the central region of the Weather Service tends to do it by growing degree day accumulation, and the eastern region is more climatological. And so we're kind of at the interface between the two regions. So, and every spring the weather's different, and so this year was kind of a little bit challenging with that deep freeze there in early April. And then we had another freeze and snow in the middle part of the month. All right. Thank you very much.
Absolutely. And just to go off of that, we do have the VIP page. That's a great resource for people as they go into the spring and the fall freeze season. Just so that you can see what the guidance is for different areas. So one thing we do is we have Weather Service partners collaborate with each other through this, and then they can basically put in what their vegetation status is Obviously, this time of year, it's going to be mostly green because it's susceptible. We shouldn't have a freeze from now, but basically it's just saying that the freezes would make it susceptible at this point. So that's a great way for Weather Service offices to collaborate and share each other's vision of what's going on in their area so that they can kind of collaborate from that standpoint for frost and freeze warnings.
All right. Well, thank you, Bryan, for going through all of that. Certainly growing degree days are something that we're certainly interested in, especially in the spring as we're trying to go through frost freeze and things like that. So the MRCC is a great one-stop shop for seeing a lot of the information that the Weather Service and others are using to make those decisions and things like that. So I don't see any other questions. So Bryan, thanks again for taking the time to present to us today. And with that, I will switch to Aaron. Let me change presenter here. All right. So next we have Aaron Wilson from the State Climate Office of Ohio. He's one of the research associates there, and he's going to talk to us about climate change in the Great Lakes region and impacts in Ohio, and stuff that's more applicable to us in the local area rather than the global scale. But I'm sure he's going to hit on a whole bunch of topics. So we're very excited for this. And so with that, Aaron, take it away.
Awesome. Zach, can you hear me okay?
I can hear you okay, and I can see your presentation, so you're all set.
Awesome. Maybe what happened here? Let's see. There we go. Yeah. So thank you, Zach, and certainly I want to echo Zach's comments on what Bryan's presentation and the MRCC. There's not a day that goes by that I do not use that site. Certainly, it's very helpful, as you all know, in answering questions that folks have there. But also just taking a look at the changes even over longer periods of time, and so that's what I'm really here today to talk about. I am with the Ohio State University. I'm an atmospheric research scientist, and so I'm here with the Bird Polar and Climate Research Center, and I'm also with OSU Extension, and so I interface a lot with the agricultural community, but others as well throughout the state. So, a lot of what I'm going to talk about today are obviously our longer term impacts on our climate, and I think these three photos are perfectly kind of sum up. Well, not in its entirety, but certainly there are three pictures that reflect the challenges that we've seen of late, right? And largely due with our water, our high lake levels, inundation of highways frequently happening across the state, and of course the inundation of our farm fields as well. And so we're going to get into a little bit of that climate change stuff today. Just as a quick background, I was raised in Miamisburg, Ohio, so since mid 90s, of course, following the Wilmington office quite closely. But before that, I lived in Miami, Florida. We moved from Miamisburg to Miami, Florida, so fell in love with tropical systems, which I don't do a lot with now, but certainly enjoy that. We had the drought in 1988, which actually forced me into retirement from agriculture. That's my retirement photo there in the bottom left. The last time I was on a tractor. No. Anyway, maybe some of you remember John Hope, the hurricane specialist at the Weather Channel, as Hurricane Hugo came ashore there. So kind of a long, winding story. Did my degrees at Ohio State, and now work at the Bird Polar and Climate Research Center here on campus as well. So yeah, we're here today to talk about these normals, right? And I love this little cartoon, what is normal temperature for this time of the year? And of course we know that typically that's anything above normal or below normal, right? I mean, normals, these long-term quote averages with a little bit of other statistical analysis in there, as Zach mentioned, are rarely met exactly on a day-to-day basis. We're usually warmer or cooler than average. We get a little more rainfall or none at all. And so it's always an interesting conversation about normal. And of course, that normal really changes depending on, what decade we're in and who you're talking to. And I thought Zach did a very good job of explaining that, this 30-year window normals with the National Weather Service, obviously, they have a specific purpose. They weren't ever designed with climate change in mind, for instance. They were an operational sense. Really under the assumption that climate was static in the 1930s when they came about. And so it's staying off the 1980s decade. Okay. Dropping off the 1980s decade and adding the 2010s. So we've seen those changes. And we're going to look at that. I guess I'm having some internet connection. Zach, you got me okay?
Yeah. You went in and out there briefly, as you were transitioning slides, but I think we've got you now.
Okay, so I'll keep going. Okay, good. Yeah, just let me know if it acts up again. I'm not sure what's going on. These are snapshots of what we're seeing, the changes by dropping those decades. But I'm going to talk a little bit more of the long-term changes, the longer view of everything, right? So this is a couple of figures. Probably many of you have seen these, and a lot of this will be reviewed here at the beginning. But 2020 is now the second warmest year on record since 1880 for the globe, and it's really only behind 2016 during that period, by 0.04 degrees Fahrenheit. Of course, that's probably well within the instrument error here, with 2019 being the third warmest. So we can see that on the right-hand side, this is just the historical land and ocean temperatures compared to the 20th century mean, and we can see the steady and rapid increase, temperature-wise, since the late 1970s, early 80s, and beyond. So now the top 10 warmest years for the globe have all occurred since 2005. Right? And I always like to throw this statistic out. If you're looking at the 20th century mean and you were born after February 1985, you've never experienced a cooler than average month for the planet, right? So all the younger audience members, probably have likely not experienced a cooler than average month for the planet. And of course, there are spatial differences, and this is the map that you're looking at from 2020. Most of the land regions, most of the ocean regions are showing warmer, or to much of, warmer, even record warmest in those darker reds, with a couple of pockets of cooler than average. We've got this concept that, freshwater melt from Greenland, cooling the surface waters of the North Atlantic. And so we've actually seen, a decrease in ocean anomalies in that portion of the globe. And that can have ramifications for very long climate timescales when it comes to things like ocean circulation. Of course, we know the ocean and the atmosphere interact. But clearly, it's warmer, right? We're under a warmer regime than we've seen throughout most of the 21st century. And this is from the National Climate Assessment, just assessing things from the United States perspective here. A lot of red, meaning looking at the last, a 30-year period, basically 1986 to 2016, relative to the first 60 years of the 20th century. And looking at a couple different statistical ways of analyzing that change, we've essentially increased about 1.2 degrees Fahrenheit over the United States, just comparing those two, right? We can get a little bit stronger change if we just look at a linear regression, but most areas have warmed between 1 and 2 degrees Fahrenheit very strongly in winter for most of us, except in the southeastern US. Okay, so let's keep that in mind. And then we'll notice the differences between winter and summer as well, right? Where more areas in summer have actually experienced flat or relatively cooling compared to the early 20th century. We can think about what's in the first 60 years, right? The decade of the 30s, for instance, that were very warm. And a lot of our records here in Ohio in terms of summer maximums are from that decade as well, right? So overall, we've seen the warmth, but we see some seasonal differences. And those seasonal differences here in Ohio, changes in seasonal temperature trends, do have ramifications, especially on the agricultural side. Looking at precip, the same thing. We've seen a general increase of about 4% in annual precipitation since 1901 here. And here in Ohio, between 5 and 15%. Now, again, Zach showed some individual station changes with the latest normals, and you saw some fall decreases, I think Mansfield for one. But overall, fall has been the season of late over the last 30, 40 years that's been a lot wetter than the first part of the 20th century. And so a lot of these trends are driven by fall, winter, and spring increases in rainfall. But we're seeing some individual months like July and August where folks in West Central and Northwest Ohio have actually seen a decrease in July and August rainfall. So you can imagine, I ask my farmer friends, what's a perfect season? They do not tell me a wet spring, a dry summer, and a wet fall. That does not lend itself to great growing conditions or planting or harvest, right? And so these are the challenges, the types of challenges we're seeing. The increase in the intensity of the rainfall as well, the ability to see 2, 3, 4 inch rainfall events in an hour or two have increased in number and scale across the state. And so I like to use this comparison here on the left-hand side of Ohio because we can break down extreme numbers and extreme precipitation in a lot of different ways. This is just looking at the number of events greater than 2 inches since the early 1900s in 5-year means here, right? And so we see in this bar graph, this chart, we've got a pretty persistent change in those extreme precipitation events across Ohio since about the mid-1990s. We've seen a steady bump up, a big jump. Now, the other peaks in the record, obviously these are 5-year means, but these years, 1913, 37, and 59, fall within those other 3 peaks, right? And those were all what in Ohio's history? Major flood years. And so the point of this graph isn't necessarily to say, pinpoint different individual events, but it's to highlight the flood risk, the water risk that we have here in Ohio's climate. You know, the eastern U.S. and Ohio is a very rich, water-rich region. I think we take that for granted a lot, especially for those that have experience out west, where that is not the case. We see our climate and our changes a lot through that water interface, right? And of course, this is all tied back and linked to as our temperatures are increasing, we're increasing that water vapor as well. We see evidence of this, increasing the amount of water vapor in the atmosphere due to strengthened evaporation. And of course, whenever we have fronts and things come along, we can squeeze that moisture out more readily. But those warmer temperatures also mean more rapid drying from the surface. And so we can oscillate between these what I call hydrologic extreme reality, between intense droughts and intense rainfall and back and forth. And the picture on the right is just another one from the National Climate Assessment, different ways of looking at those heavy precipitation impacts, right? And how they've increased, the 99th percentile, the 2-day events, and we often hear these 1 in 1,000 year events happening a lot. What does that mean, right? It's all statistical. What does that really mean? So again, this figure on the right is, I want to credit Sarah Jameson. I know that she's left us from Ohio now, always a great partner with the State Climate Office, and we wish her luck. But putting together the natural disasters, more than $200 million on rain-related disasters between 2008 and 2017 here in Ohio. That just reflects the type of challenges that we see from flash flooding and flooding, these heavy rain events. And of course, we have tornadic damage and things like that as well. But a good portion of our change, right, our climate is focused in that water and the changes as well. And of course, we know across the country, last year was an extreme year for our billion-dollar weather and climate disasters, and certainly the last decade, the 2010s, were up there in terms of the top years of those billion-dollar disasters. So we're talking not only the averages, but these extremes are now captured in these new normals, right? Those extremes that we've experienced over the last couple decades, just like in the 1930s when we had climate normals then, or the 1950s, those are still part of that long-term difference. But if we just throw up a table here of the top 10 warmest years in Ohio and top 10 wettest years in Ohio, and by the way, data pulled from the Midwestern Regional Climate Center, of course, it's based on the NCEI data, but again, an example of how effective and how easy it is to get good data from MRCC. The top 10 or the top 8 warmest years, or 8 of the top 10 warmest years and 8 of the top 10 wettest years for Ohio have occurred since 1990. So you drop off the 1980s, you add the 2010s, we're putting these extreme years in those new normals. And that's why we've seen that push, right? That in terms of this snapshot. And just looking at, the last several years of rainfall, 2017, 2018, 2019, all in the top 10. We know what planting was like, for instance, in the Northwest for 2019, pretty much non-existent. So we are warmer, we are wetter, but there's a lot of details in there and a lot of impacts that we want to get to. We do expect temperatures to continue to warm. We see mid-21st century 3 to 5 degrees warmer over our contemporary climate. We see more precip, especially in winter and spring, but the propensity for more drought as well in the summer due to shifting atmospheric circulation. A lot of this driven by that water vapor and evaporation precipitation cycle, that hydrologic cycle that we have, and based, combination of that and the atmospheric circulation changes. So we can have wetter, cool seasons and drier summer seasons back to back. We've seen those frequently over the last several years, and we expect more of that as we move through the next 30 years here out of our models. So, that's just kind of the brief. Okay, so what's happening in Ohio and what do we have to contend with? Let's start breaking down some of these impacts that are really important. And we think about the increasing temperatures. From an ag perspective, yeah, that has additional livestock implications, needing additional cooling capacity for livestock across the state, but also humans, right? Our farm workers, our parks and rec, our city workers, and the like. Anyone who works outdoors having to deal with, higher levels of humidity, sustained heat stress, for instance. Ohio, cities throughout Ohio are growing. I have an example here of Columbus with a very strong urban heat island where inside the city could be upwards of 24 degrees warmer than outside the 270 belt, right? Very intensifying urban heat island. That impacts vulnerable populations that live within the city. And you think about that adequate cooling needs, right? Lower food productivity and reduced quality. Warmer overnight lows during the summer because of higher levels of atmospheric moisture versus daytime highs, but that drives the energy use and the food production during the night. That can lead to reduced quality in our fiber and different food products. Increased weed pressure, insects, and potential disease. We've seen shifts in our growing zones to the north and west. We've seen a climate in Ohio over the last 100 years become more conducive to different pests that we didn't see, that were sort of isolated to the southern reaches of the U.S. We think about health impacts from things like mosquitoes, right? That carry tropical diseases, and now we have mosquito species that can bring West Nile or Zika or other types of tropical diseases here farther north. And of course, these are all non-native plants that are out competing typical animal and plant ranges. If you're here in Columbus, maybe not so much up in Cleveland, but certainly here in Columbus, if I want to get the feathers ruffled around campus, I talk about our Buckeye tree moving to the state up north, right? That's something that we talk about in terms of overall progression. That's one species we talk about that is shifting its zone farther and farther north with time. Not to kind of ignore benefits, if we think about from climate benefits, longer growing seasons, the potential to grow double crops, for instance, in some places of Ohio, maybe saving on money from certain, things like salt or road maintenance. And we'll get to that in a second with the variability with road maintenance, right? But with our late spring freezes occurring earlier and our first fall freezes occurring later, we're generally opening up the season. But that leads to other additional problems. We see a lot of variability in our late winter, early spring, right? We know with changes in the Arctic and warmer air surging north, though there's a lot of research still taking place on the interactions between the Arctic and mid-latitudes. After all, that's cold air, and that cold air has to go somewhere, and it's not going to climb the Rocky Mountains. So those polar vortex outbreaks that we so passionately call them these days, but that colder air has to sink down somewhere. And so we can get these late season freezes after really mild false springs is what we call them. So those fall springs cause plants to bloom earlier. They create unpredictable growing seasons and disrupt a lot of our important bird and insect connections and other wildlife as well. And then we become more susceptible to different diseases and different freezing events. High variability in the winter. What does that create for Ohio? If we're not famous for orange barrels, and transportation obviously that's part of this call. But obviously, you know, we're working on roads a lot. The high variability in our temperatures leading to more potholes and road maintenance throughout the late winter and early spring as well. There's a great report from the Environmental Law and Policy Center here, and I provided the link as a PDF report looking at various different Great Lakes as a whole and some of the challenges that they're seeing. So from recreation, tourism, fishing, you know, thinking about Lake Erie and its important impacts, local businesses along the shorefront, you know, ice cover duration. We haven't really seen big trends in ice cover in terms of duration, except for maybe the northern extent of the lake. But certainly we've seen some marginal trends in terms of increasing summer surface water temperature and into the fall as well, where we maintain warmer conditions later in the season, and that can leave the lake open and susceptible to cold northerly and northwesterly breezes that actually can provide more moisture to lake effect impacts. So there's some uncertainty, you know, between a changing climate, what we're seeing, and an increase in the lake effect snow, for instance. The time series of maximum ice cover since the 1970s has generally been a decline, and this is for the Great Lakes as a whole. And that onset or the first, you know, the freeze up date becoming later in a lot of respects as well across the Great Lakes. We've seen larger changes across areas of like Lake Michigan and Lake Superior, but still some changes here along the Lake Erie shorefront as well. So when we think about impacts from precipitation, right? Greater general flood risk. This is a common sight that we saw for the last 3 or 4 years across Ohio and really the last decade, just these inundated fields with water. I mentioned the flood risks that are associated with frequent inundation of water as well and into our cities, increased transportation issues. The number of times I-70 has been flooded east of Columbus, 71 south of Columbus, I-80, I-75, different highways where, you know, our transportation's built on these historical precipitation trends that have obviously shifted very rapidly in the near term. And we're trying to catch up, right, to create drainage situations that can really help mediate this water. This all brings about reduced water quality and that intense runoff and contamination. I can tell you, farmers do not want their nutrients in their soil moved off the field, but this is what's happening because how do you withstand, you know, 4 or 5 inches of rain in a matter of an hour or two, right? How do we build resilience? I think that's the question that we have in front of us. I don't have the answer, right? How do you keep 5.5 inches of water in an hour from completely inundating a field, right? Those are the types of questions that we're thinking about. Increased cost associated with clean drinking water, right? To keep toxins out of the water, for instance. And again, the potential for summer droughts and seasonal water shortages. From an agricultural perspective, we've lost our planting and harvesting days in April and October. So this is according to the data is from the National Agricultural Statistics Service. Since mid-1990s, we've lost 5 days of suitable fieldwork conditions in October and April. So these are planting and harvesting times, and so farmers are having to do more in less smaller windows of time, and also in less optimal conditions for their fields as well. So again, I mentioned earlier 5.5 inches of 2 hours, northern edge of Arcanum a couple summers ago, the flooding out by Buckeye Lake here on I-70. And of course, all of that water then fills with nutrients, fills with, you know, soils, and then our waterways are impacted. So things like harmful algal blooms on the western Lake Erie Basin, the Muskingum River, Ohio River. These are all, you know, potential for this. And of course, this is not desired by anyone. This is not being intentionally done, but we have to think about how we're managing our nutrients, and also with respect to these more intense rainfall events across the state. Of course, we're coming off a period now across all of the Great Lakes where the water was really high. I don't have to tell you folks that live up there, right? So we've had really high water levels for the last several years, and the future impacts of the Great Lakes levels is a little bit less certain. You know, where maybe earlier reports several years ago would talk about long-term water drawdown. You know, a lot of this becomes complex when you bring humans in, thinking about water usage. You think about, how much water's falling across the Great Lakes Basin. I think that's what we really saw in the last several years. It's just the whole basin, Wisconsin, Minnesota, Michigan, Ohio, Indiana, just a tremendous amount of water falling across a lot of these areas. And that really helped drive up the water levels on all of our lakes. Thankfully, they're starting, they've come back down now from their record levels, but we still have some uncertainty here. But certainly, with high water levels, more shoreline inundation, more flooding, more damage, and again, folks up there, you've experienced that time and time again now over the last couple of years with this, combined with high wind events and storm activity on the lake, complicating factors here in terms of impacts. More complexity with impacts to ecosystems, invasion by non-native species in our Great Lakes, not necessarily just finding their way here naturally, but brought in through transportation and trade and things like that, but then thriving, right? So the complex relationships of how do these species then thrive in these environments. I'm a birder myself, so certainly Ohio is kind of a gateway, right, for a lot of migration and spring migration of birds. There's a great report from the Audubon here looking at, 2/3 of American birds increase risk because of global temperature rise. We're losing a lot of habitat here in the lower Great Lakes, and we're expected to lose more as we continue to warm here in the future. But that's certainly, I think, from a tourism and attraction standpoint, that has an economic impact on local businesses around the lake, notwithstanding the impacts to the natural wildlife as well. So as you can see, the changes that we're seeing, there are a ton of impacts here locally and across the state that have important implications and are very important to talk about. So I'll round out my talk a little bit, background on SCOO's history, the State Climate Office here, which has been retained at Ohio State since 1973. As Rayleen mentioned, Bryan Mark is the state climatologist, but I work primarily through extension and a lot of the agricultural services. And we're focused on climate communication, information services, education, outreach, and research. And so we really want to help be data stewards to connect Ohioans with weather and climate information necessary. So, just considering us a partner, right, and working, and we have a lot of collaborations with you and work really closely. Again, I do a lot with the agricultural services, but I'm also help coordinate the U.S. Drought Monitor weekly web. Right now for Ohio, it's a listserv. Basically, we chime in each week and kind of coordinate the suggestions to the weekly U.S. Drought Monitor. So Nick Greenewald up there now with National Weather Service in Cleveland. So we do drought monitoring and really kind of work with OMEA, National Weather Service, Department of Ag, and ODNR. Work really closely with the regional partners, the director of the Midwest Climate Hub, Dennis Toddy. We work really closely with him, thinking about Ohio to the Midwest connections. With Doug Cluck out in the central region, Ohio is sort of on the periphery of the central region and the northeast region. So Doug has sort of brought us under, his arm here across the north central region as well. Locally working with municipalities to think about climate adaptation plans. We've done it here in Columbus. We've, had communication and worked in different workshops with folks in Cleveland as well. And also on the research side, integrated modeling, downscaling modeling, with climate adaptation as well for impacts with private companies like Honda and Owens Corning. We're working right now, and I think this is interesting for the National Weather Service, with CFACE Worcester to bolster their ag weather research network stations. These were designed at research ag stations and have been around for a while, so they're not necessarily optimal for National Weather Service operation. But we've been trying to do things like we've added multiple levels of temperature and humidity, for instance, to look at inversion monitoring. Can we monitor for inversion? That's really important from a spray drift perspective. Added some soil moisture sensors to 4 sites to increase our in situ observations of soil moisture across the state. And we've also used national weather products like the Peake UPF to design this farm field application resource monitor for farmers that are applying fertilizer and manure applications, just using that data to provide 12 and 24-hour precipitation windows that are basically aligned with the fertilizer and manure application regulations for the Western Lake Erie Basin. And of course, you have to have social media, and we follow the National Weather Service social media, but we have our own Ohio Climate Facebook. We're kind of shifting from a quarterly climate summary to a monthly climate summary that we want to have available on our website there at climate.osu.edu. We were doing weekly hydro and climate assessment updates. We're kind of tailoring those a little bit differently in the future, but still, climate.osu.edu is our home base here for the climate office. And of course, there are a lot of different reports and links that I have in the PDF. I don't know, Zach, if you're going to make that available, but there are a lot of reports with the National Climate Assessment, the latest warming of 1.5 degrees C, a lot of different documents to take a look at and certainly think about it through an Ohio perspective. So with that, I'll go ahead and conclude today. You can always reach me at wilson.1010@osu.edu or at climate.osu.edu as well. So thank you, and I'll turn it back over to you, Zach. Thanks.
Aaron, thank you so much for your presentation. I think that climate change obviously has many impacts across the state of Ohio and the lower Great Lakes region, and you really hit on a lot of the highlights that we've been dealing with. Certainly we've been experiencing, the harmful algal blooms in the western Lake Erie region and the lakeshore flooding that I know that has been a large impact even as recently as this past Memorial Day weekend. So, certainly we appreciate it. So, any questions for Aaron? I don't see any hands raised, and of course, we'll have all the presentations and handouts given to everybody in the coming week or so once we compile it, and we'll have a handout, with all the links and things like that. So if you want to explore on your own, absolutely, there's a lot of resources that we threw at you today. So again, I just want to thank Aaron and Bryan for taking their time out of their day to help us with this workshop, and then Raelene as well, helping me with the climate program here at National Weather Service Cleveland. Obviously, climate's just something a little bit different than just talking about severe weather preparedness, winter weather preparedness, and flooding, because it's the one thing that certainly has a larger impact across the region, and something that we talk about day to day with things like normals, or on a longer term with climate change and things like that. So with that, I've got noon, so we'll end the webinar. And thanks again. And if you've got any questions, feel free to email me or any of the presenters. And again, we'll get the information to you here shortly. So thank you so much, and you all have a wonderful day.